Hey mathletes, in this lesson we're going to look at exponential growth and decay. So remember, an exponential equation is one that has the independent variable x as an exponent. So here we've got a graph of y equals 3 times 1.2 raised to the x. This is what the table would look like. So in this table we can see the parts of this equation. Remember, anything to the 0 power is 1, so the y-intercept would be 1.2 raised to the 0, which would give you 1, and 1 times 3 is 3. So anytime you have x is 0, whatever that value is, that's your starting value. In this case, your y-intercept on the graph. When you want to know what the growth factor is, what it's increasing by, all you would do is take a consecutive number and divide it by the 1 in front of it. So 3.6 divided by 3 is 1.2. This is the growth factor. The growth rate would be 0.2 or 20%. So if we're looking at this table and we want to write our exponential function, we want to look at some things like, what is it increasing by? Making sure that x is going up by 1, 0.6 divided by 0.2 is 3. 1.8 divided by 0.6 is 3. So we know, again, 5.4 divided by 1.8 is still going to be 3. So we know that 3 is our growth factor. Our growth factor is 1 plus something. So our growth factor is 3, which means our growth rate is 2, which is really 200%, because your growth rate is a decimal percent increase. So 2 as a decimal is 200%. Our initial value, that would be where x is 0, our y value is 0.2. So the initial value here is 0.2, and of course it's raised to the x. So y equals 0.2 times 1 plus 2 raised to the x. Now we have two different kinds of exponential growth and decay. It's either continuous, which means it happens constantly all the time, or it's periodic. Continuous growth is something like the amount of medication in your bloodstream after you take some medicine, or population growth. So periodic growth is something like an investment account or money in your savings account or something like that. So P0 is an initial value. That's what you start with. 1, if you multiply something by 1, it doesn't change. So if you're adding a rate, it's positive. If something is decaying, you're subtracting a rate. N would be the number of times that happens. So if it's every 6 months, every day, and then T is usually the number of times that happens. In continuous growth, you start with the initial value, but it's multiplied by E raised to the rate times time. Now E is something called Euler's number. It's like pi. In this case, Euler's number is 2.71828 and just goes on forever. R is your rate as a decimal. So if it's growth, it's positive. If it's decay, it's negative. And T is how long this is happening. So here we got a case where you take some, say, 800 milligrams of ibuprofen for a headache. Your body processes it continuously at about 8% per hour. How much is left in your bloodstream after 6 hours? So since this is continuous, we know we're going to use E. So we're starting with 800 milligrams times E. Since it's being processed, it's leaving your bloodstream, so it's going to be a negative. 8% is 0.08. And we want to know how long after, or how much after 6 hours. The nice thing is with something like this, you literally just type it in the calculator. You just need to make sure you set it up correctly. So 800 times E raised to the negative 0.08 times 6 is 495.026 milligrams. Now it's going to tell you in the question what to round it to. Usually it's rounded to the nearest tenth. That's the second decimal. So we'll look at the third decimal, If it's 5 or up, we're going to round up. If it's less than 5, we're going to round down. So since this is 6, we're going to round up to 0.03 milligrams. Okay, this is one of those cases where you are earning money in an account. So Chloe has invested $5,600 in an account. It pays 5.3%. It's compounded daily. So if we're not taking any money out, how much is going to be there after 7 years? So we got to make sure we get everything in the right spot. So 5,600 is what the account starts with. 1 plus a rate. In this case, they're paying you interest, so it's positive. 5.3% is 0.053. They're going to compound it every day, so the number of days in a year is 365. Remember, it's the number of times you do it times how long it's happening. So in this case, it's going to be 365 times 7. Again, the nice thing about exponential functions like this, if all you're trying to find is y, once you set it up, you just type it in the calculator. You just need to make sure you type it in correctly. So after 7 years compounded daily at 5.3%, Chloe's going to have $8,115.20. They want the nearest $100. So since the 1 is the 100, I'm going to look at the number to the right of it. It's a 1. It's less than 5. So I'm going to round that down to $8,100. So the important thing is when you're evaluating exponential functions, you know how often it's compounded or if it's compounded continuously. If it's continuous, you're going to use e. If it's compounded on a regular basis, just plug that into the function.